In this video, we're going to take a look at determining the equations of vertical asymptotes and finding the coordinates of any holes in the graphs of a rational function. So first up, going back to domain, recall that the domain of a rational function is going to be all real numbers except the values that will cause the denominator to equal 0. So at each of the values that will cause the denominator to equal 0, then one of two things is going to happen there at each one of those values. Either we'll have a vertical asymptote, which really distorts the behavior of the graph pretty significantly, very noticeable, or there's going to be a hole in the graph. And with holes in the graph in technology, unless you can trace over the graph, it won't, at first sight, look like there's anything special going on that part of the graph. But if you were to trace over it, you would get some information that there is actually a hole there. So a vertical asymptote, first up, is a vertical line that the function is going to approach but never intersect. So with holes in vertical asymptotes, it can never actually equal, the function can never actually equal that value of x. But with vertical asymptotes, the behavior of the graph around the function is as the function gets closer and closer to a vertical asymptote, the graph is either going to skyrocket upwards towards infinity or plummet downwards towards negative infinity. It's very noticeable on the graphs that that is actually what's happening. So here I have an example of a graph that has a vertical asymptote at x equals -1. So as we get closer to the vertical asymptote from the right, this particular graph goes up forever. As we get closer coming in from the left, it's going to sink down forever. Now, again, it's very important to remember that this graph will get infinitely close to the vertical asymptote, but it'll never actually hit the vertical asymptote. It can never actually intersect this vertical line. The closer that it gets, the further it pulls it down. So it's kind of like warping the space-time continuum. So with holes in rational functions, most graphing technology will not show holes in the graph upon sight, which is actually not very comforting to know, because you could look at the graph of a rational function and just based on its appearance, even using something like Desmos or whatever happens to be around, it won't tell you necessarily that there is actually a hole in the graph there. So how to tell your asymptote from a hole in the graph? First up, you're going to factor both numerator and denominator completely and then simplify that. So if you need a little bit of a brush up on factoring, I recommend, I have some factoring technique videos in other math courses I have on my YouTube playlist. So for each domain issue in the denominator, so when we factor our numerator and denominator and we look at which values of x would cause the denominator to equal 0 after factoring it, if you get a 0 in the denominator after you evaluate the simplified expression, we're going to see some things hopefully cancel out. Terms in the numerator and denominator hopefully cancel out. So if you evaluate that value of x and you end up with a 0 in the denominator, which we know we don't want, you're going to have a vertical asymptote at that point. Otherwise, there's going to be a hole in the graph there. Now, one of the nice things about vertical asymptotes is you can check those values of x on the graph, the ones that would cause the denominator to equal 0, and if it has that warped appearance to it, you know there's got to be a vertical asymptote there. If it doesn't look like anything special is going on, then you'll know that there has to be a hole in the graph there. So you can also use the graph as well to help you. So to get the y-coordinate of a hole in the graph, after you simplify your rational expression, plug in that value of x into your simplified expression. So let's take a look at some examples. So we'll do a couple in this video and then a couple more in the next one. Determine the domain of each. So going a little bit of review there. Then determine the equations of the vertical asymptotes and or coordinates of any holes. So we're going to start with 2x over x squared minus 9. We're going to factor the numerator and denominator completely. Our denominator factors is x plus 3 times x minus 3. It is a difference of squares. So notice here, there's nothing to cancel out. No x plus 3 terms in the top, no x minus 3 terms in the top. So there's really nothing to cancel out. Our domain is, if we set x plus 3 equal to 0 and x minus 3 equal to 0, we don't want x to equal negative 3, and we don't want x to equal positive 3. So our domain is all real numbers except these two values. So I'll just use a set builder notation here. But we have reviewed how to write this in interval notation as well. So each one of these values of x is either going to be a vertical asymptote in the graph or a hole in the graph. So let's take a look at what we have here. So if we put zeros, if we put negative 3 and positive 3 in for x, we're going to get zeros in the denominator. So we're going to have, because we get zeros in the denominator, both at x equals negative 3 and x equals positive 3 are going to both be vertical asymptotes. And those are the equations as well. Remember, vertical asymptotes have the equation x equals where they hit the x-axis. So if we graph this, I know I didn't really give a lot of room here, but that's okay. Hopefully you can trust me. We had 2x over x squared minus 9. And we'll zoom on in. So notice here, we'll put in, here we'll do a graph of x equals 3. Here we'll do a graph of x equals positive 3. So notice as we get closer to those vertical lines, our graph starts to sink downward forever, so it has that vertical asymptote behavior. There aren't going to be any holes in the graph because we couldn't simplify anything. We didn't have anything to cancel out in the numerator, so there's not going to be any holes in the graph if that's the case. All right, part B, we have g of x equals x squared minus 6x minus 7 over x squared plus 5x plus 4. If we factor the numerator and factor the denominator, we get x plus 1 times x minus 7 over x plus 1 times x plus 4. Our domain, x is not allowed to equal negative 4, so x plus 4 can't equal 0, which means x can't equal negative 4. X plus 1 can't equal 0, which means x can't equal negative 1. So at each one of these values, we're going to have either a vertical asymptote or a hole in the graph. If we simplify this, we can cancel out these x plus 1s. We get x minus 7 over x plus 4. So if we test out the negative 4 into this simplified expression, x minus 7 over x plus 4, if we plug in negative 4, we get a 0 in the denominator, which means there's a vertical asymptote at x equals negative 4. So we can actually graph the original function and see that as well. So I'm going to graph the original function. It was x squared minus 6x minus 7 over, what was it? X squared plus 5x plus 4. So let me graph x squared plus 5x plus 4. And if we look at x equals negative 4, we zoom out a little bit, notice we do have that vertical asymptote behavior. Our other value of x that we couldn't have in our function is negative 1. And if we look at our function at negative 1, it doesn't look like there's anything special going on in the graph. But if we zoom in a little bit, when we get to x equals negative 1, look, there's a hole in the graph right there. So again, upon just looking at what Desmos gave us originally, it doesn't look like anything special is going on at this value of negative 1 for x. So if it doesn't look like the graph's getting warped around that value, that means there's a hole in the graph there. So how do we find the y-coordinate of that hole in the graph? Well, we just take this simplified expression that we have and plug this x value of negative 1 in. So negative 1 minus 7 over negative 1 plus 4, we get negative 8/3. So the y-coordinate of this hole in the graph is at about negative 8/3, which is about negative 2 2/3. So a little bit tough to see on the, in between the negative 2 and negative 3 here, but that is our y-coordinate of that hole in the graph. So again, to get the y-coordinate, just plug your value of x into the simplified expression. So the coordinates of our hole in the graph are at negative 1, negative 8/3. So here we have a vertical asymptote and a hole in the graph for this equation. All right, that about does it for this video. We'll do a couple more of these in the next video, so I'll